powering one of these with one of these today on Mikey's Lab. Today we have another power related device coming to you. This is a one-day build. It's a quick little hack that will help our sister channel who shoots with handy cams. And one of the things that we've learned over this winter, since it's a fishing show and does a lot of outdoor shooting, lithium-ion batteries don't like the cold. So what we're going to do is we're going to hack the wall adapter for the camera, which we never use because, again, it's a fishing show and wherever we go there's no wall power. We're going to take a look at the voltage rating that this puts out, and we're going to create a device that will allow us to take lithium polymer batteries and generate the voltage required for the camera. So lab code up. We're going to learn something today. Alright, so let's just dive right into this. But we're going to need to get this job done. We're going to need some hot glue. Alright, I'm going to include a blue LED. We have a battery protection circuit. This is very important when using the LiPO batteries because these batteries will literally provide power till they can't be charged anymore. This will make sure that we stay in the safe range and that these never get below 3 volts per cell. We have our friend that we've used many times here, the voltage regulator. Because this is going outside and with a bunch of guys that I know very well, we're going to put this into a tough project box. We are going to use a balance lead extension for the LiPO battery in order to access the voltage. We're only going to need a couple of amps from the battery at a time, so we're just going to get them through the balance lead. We need some silicone wire. For the same reason that we use the silicone wire in the rover, temperature-wise, the other types of wire can get brittle and fray, and it just turns into a mess and is difficult to work with, so we're going to use the good quality wire with this. We are obviously going to need the action cam or the handheld camera to test with. So let's take a look at what we're building. If we look at the actual power adapter, I don't know if you can see it on your screen or not. Right, but this outputs 5.3 volts at 1.5 amp. So we need to replicate 5.3 volts at 1.5 amp. These are obviously 3-cell batteries. They're the ones that I happen to have, so these are much higher than 5.3 volts, hence the regulator. But we should be easily able to provide 1.5 amp from that. So what I'm going to do is I'm going to open up this project box here. These are somewhat waterproof. It will be somewhat less so when we're done. Okay. And the layout that I'm thinking for most of the stuff is just like that. And it'll be hot glued in place with the wires connecting everything that need to be connected. We'll have the balance lead coming in from this side, and we'll have the camera power coming out from that side. Alright, so the first thing I want to do is go ahead and start the soldering up of this. Now these balance extensions that I have, I don't know if you're going to get a similar one. It's very important to identify which one is ground first. Absolute ground on mine is the outside black one, and absolute positive is the red one. So we're going to go ahead and I'm going to grab my wire snips. Let's try this one. If you look at the board, you can see that there's a negative battery voltage, 7.4, 11.1, and 3.7. So the negative, the one beside the negative, the one beside that one, and then the positive get connected to these. So those are the connections that we're going to do first. So I'm going to go ahead and leave myself a little extra room here for every every one of the cables. We'll shorten them as we actually solder them in place. So I'm just going to cut the 4 wires of the extension like so. Alright, I'm going to get some of this stuff out of my way. So, now that we have the parts for this step already done, we're going to go ahead and tin everything up. A little solder on the soldering iron to tin the tip, because this is a hell of a pad to tin. Again, this particular BMS is capable of delivering up to 25 amps, so it has some beefy conduits that are going to be a bit of a pain to heat. It might take a little while, so be patient and make sure you get a good solder tin to the pads. Make your life a lot easier later on. And you can tell, I don't know if you can see it in the camera, when the pad gets hot enough, because the solder just starts to flow across the entire pad. And that's obviously what we want. Plastic table might not have been the greatest choice for this, but it's a lab bench. Recently had a conversation with one of my older friends about soldering. It's very important to understand what a cold solder joint is. You'll notice that with these solder joints, the solder is shiny. That means that everything that was in contact and was supposed to be soldered has become hot enough. Cold solder joints, especially with high-speed communications, can pose a lot of interesting problems. So always make sure when you're done soldering that your joint is shiny. If it's not, apply more heat. There we go, that board is tinned. We'll let that cool off for a minute. We'll move on to the voltage regulator, and we're going to tin all 4 pads on that one as well too. Alright, clean the soldering iron, and we'll go ahead and put that there for a second. Okay, so as we said, our chosen layout is like this, with power leads here, right, and then this is going to come in this way. So absolute battery minus and 7.4 volts have to come all the way to the bottom, and then these 2 will be up at the top. Alright, you go ahead and grab my wire strippers, and we're going to strip the balance leads back a little bit. There we go. Now I know I've mentioned this in other videos, but I'm going to mention it again anyway. When you're working with LiPO batteries, these things can be dangerous. Test as you go and be careful every step of the way. What we're going to do now is we're going to tin the leads coming off of this balance lead extension that we've cut apart. Alrighty then. Clean the soldering iron again. You know me, nice clean tip. Still running on the original Heiko tip several years later. Okay, so if we look at this board itself, absolute negative is right here. So I'm going to go ahead and turn this way. We're going to solder absolute negative in place, making sure that both sets of solder melt fully, and then re-solidify to ensure we have great contact there. Okay, So then 3.7 volts is the next. And once again, we're just going to melt both pads completely. There we go, that's better. Okay. And then 7.4 volts is down here. And we're doing the same thing again. Make sure both melt entirely. Then remove the heat. And let it resetify. And then absolute max nominal voltage of 11.1. Melt the joint entirely and let it resolidify. Alright, so now because I do not trust lithium polymer batteries as far as I can throw them, they're awesome batteries, but you just got to be careful. I'm going to plug the BMS into the balance lead and make sure we have no fire, first off. Second off, I'm going to grab my multimeter and I'm just going to make sure that the BMS is working. I know that this battery is fully charged, so I should be getting 12.6 volts from the main power outputs here. I'm just going to bring this to where you can see it better. And we are getting 12.51 volts. Perfect. Okay, so we can go ahead and disconnect that LiPO battery and keep our multimeter handy because we're going to need it in a second. Okay, so the next thing we're going to need, I've used all my red and black silicone wire, so we're going to have to deal with yellow and green. Why not? Just going to take a longer than I need length but short length off of here for yellow and green. Alright, the silicone wire can get out of our way. Okay, so again, strip and tin. Sometimes I think I sound like a broken record with these projects. We always do the same, do similar things, and they all have similar steps. So I apologize if you've heard me say strip and tin about 4 million times since you've subscribed to this channel. We're going to go ahead and tin this one too. And we're going to clean the tip of the soldering iron again. For those who haven't seen it before, this is a relatively clean tip. This is what yours should look like when you put it back into the tray every time. Okay, so obviously we're going to go ahead and we're going to use the yellow one for positive and the green one for negative. We're going to go ahead and once again grab our soldering iron. We don't need to tin it because everything we're soldering is tinned. So we're going to grab the yellow wire, and once again we're going to heat the whole thing up to make sure the entire, both globs of solder melt. And let it go. Sometimes blowing on these big pads make it a little easier for it to solidify a bit quicker for us. And we're going to do the same with the green. Okay. So then, just like I said before, we're going to go ahead and figure out how this is going to sit in here. And I'm going to be smart this time, and I'm going to get my glue gun preheating rather than have to wait 20 minutes in the middle of a project. Just going to plug this in like so. Since all the soldering is done, we can go ahead and permanently attach this circuit into here. And in the meantime, I'm going to go ahead and strip and tin these. No, I got to measure the distance, don't I? Of course. Okay. in we're going to have around there. Okay. And the ground is going to need to be around there. Hopefully I just did that all on camera. Bring that back. These are smaller pads, so when I strip I want to expose a little less of the wire. Okay, alright, and take this out of there. And we're going to tin those. I'm going to solder this one in this way because of how this is going to fit into the case. Just want to make sure that I didn't just cause a short. No tone. Okay. There we go. Still not hot enough. Only thing I hate about my glue gun is it takes forever to heat up. Okay, so the next step that we can do is we can set the voltage coming out of the voltage regulator. We know that we want 5.3 volts. So I'm going to power this up once again. And see where we are coming out of that regulator. Right now we are at, well, that's weird. Okay, give me 1 second. Maybe there is a short going on this particular regulator. Alright. So I have a brand new regulator here. What we're going to work with instead. Let's disconnect the battery. This is why the battery management circuit is so vital. It does the overcurrent discharge. It protects against discharging itself, short circuit protection. It makes this whole project much safer. So we're going to go ahead and just sub in a different voltage regulator. Okay. Let's try that again. We'll power up the circuit. And we'll see what we have coming out the other side of the regulator. It's like the voltage regulator's battery management system is not allowing this to power all the way through for some reason. Okay, so where we are right now is every time I connect the regulator, I'm getting a voltage breakdown. Now what that tells me is that the BMS is going into a battery protection mode. Almost as if there's a runaway current. I don't know if the BMS is at fault. I don't know if the regulator's at fault. I'm going to try one more test. I'm going to connect a motor directly to the output of the BMS and see if I get a voltage breakdown under any load. But I'm probably going to have to revisit this one. So stay tuned for part 2. But let's go ahead and do that final test. and see if I can determine what is causing that voltage breakdown. Alright, so we're going to go ahead and remove the voltage regulator from this equation. We're going to attach this lead that I'm using for the rover motor controller testing. We obviously don't want to run a motor along through the balance lead alone, but brief test will tell me if there's a voltage breakdown or not. So we have that there. We're going to go ahead and connect our LiPO up. Then we're going to go grab our motor. And I have no voltage breakdown with a motor attached. So I guess the next thing I need to do is I need to figure out what it is about those linear regulators that is causing the BMS to freak out and try to protect the battery. So as I said, stay tuned for part 2 when I figure out what is going wrong with this. Thank you for joining me in the lab. I hope you learned something. If you haven't already, go ahead and click that subscribe button down below to ensure that you stay up to date with everything going on in our lab. I will see you next time.